With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, 10 ohm and 20 ohm are separated by a distance that is 10 centimeter and connected in parallel across a cell of EMF 200 volt. The negligible internal resistance, okay, where AV of mass L, that is 1 gram mass, and length 1 centimeter is balanced exactly between them. Then what must be the current in it? Okay, let us first draw the circuit here. This is our diagram. Let us consider this is where there is PQ and this is RS, okay, and this wire has that is resistance R equal to PQ has the resistance that is 10 ohm and RS has the resistance that is 20 ohm, okay, and EMF of potential is 200 volt. This is of 200 volt, okay, so current will flow in this direction, right, as both are in parallel combination. So we can calculate the current one, that is consider in this branch current is flowing, that is I1, and for this branch current is I2, and let in this wire current is flowing, that is I3, okay. So here will be the same potential, that's why current flowing through this will be how much, that is I1 will be I equal to V by R, okay. So V is 200 volt divided by resistance 1, that is 20 ohm. So current is coming, that is 10 ampere for RS circuit, okay. This is 10 ampere. For this PQ circuit, I2 will be, that is V by R2, 200 volt divided by 10, that is 20 ampere current is flowing through this PQ circuit, okay. And distance between this PQ and this wire AV, this is where AV is, that is given 5 centimeter, okay. So we can convert it into meter, that is 5 into 10 to minus 2 meter. Here is also 5 into 10 to the power minus 2 meter, okay, because it is saying that PQ and RS have the distance that is 10 centimeter. So this wire AV is balance just between this wire PQ and RS, okay. That's why that distance is 5 into 10 to the power minus 2 meter, right. Now what will happen is, if we're going to use this magnetic concept, okay, so force between these two, let us consider this is force between where AV, that is 2 and 3, force 2 and 3, I2, I3, right, and force between these two where is, if we consider, that is F1, 3, okay, and on this where there are three forces are acting, one of its own weight mg acting downward, okay, and F13 is attracting by this RS wire, and F23 is attracting by this wire PQ. That's why if we're going to balance this all forces, so force that is 1 3 plus mg equal to force due to PQ wire, okay, 2 3, okay. And one thing we know, that expression for this force between two parallel wire carrying the different current I1 and I2, we can get their force between these two, that is, if you consider 1 3, then it will be mu naught by 4 pi 2 into I1 I3 divided by distance between these two wires, that is given here 5 into 10 to the power minus 2 meters, so we can take it as a constant term, that is a distance between them two, and into length of this wire AV, okay, length of this wire AV, okay. This is the expression. Now we are going to use this similar expression here, okay. So this is mu naught by 4 pi into 2 into I1 I3 divided by distance between them is a, let us consider, plus mg equal to mu naught by 4 pi 2 into I2 I3 divided by a, right. So from here what we get, that is 2 into I3 divided by a into, that is mu naught by 4 pi, we know that value is 10 to the power minus 7, okay, into, that is, we have forgot to mention L here, this is length of the wire AV, right. So this will be I1 minus I2, okay, plus mg equal to 0, right? If we multiply negative sign on both sides, so what we get, that is 2 into I3 into 10 to the power minus 7. Okay, we're now going to put this value of A. Okay, this is A is 5 into 10 to the power minus 2 meter. Okay, into this is I2 minus I1, and we have already found out that I2 minus I1. Now we can put the value of I1 minus I2, that is after adding multiplying negative sign on both sides, it will be I2 minus I1. So I2 is 20 ampere and I1 is 10 ampere. I2 is 20 ampere minus 10 ampere. Okay, this is equal to mg. Okay, mass is given, that is 1 gram, so we can directly take it as 10 to the power minus 3 kg, and acceleration due to gravity, that is 9.8 meter per second square. Okay, so further solving it, we are getting here, this is 10 to the power minus 6, 10 to the power minus 4, 10 to the power minus 3, so this is coming 1098, right? This is 2 by 5 into I3 equal to 98. Okay, and here length is there, length. Okay, we have forgot to mention the length here. So length is given, that is 1 centimeter, I think. So if you convert it into, here length is given, that is 1 centimeter. If you convert it into meter, so we will get there in the denominator, that is 100. Okay, 100 meter. Okay, now what we are getting our current I3 as 24500. Okay, and this is in unit ampere. This is our answer. So if 24,500 ampere current is flowing through this rod AV, then it will balance by both the wire PQ and RS. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.